Good morning, Mr. Brian and Games.
Hello, how are you?
You're doing good, sir. How about you?
Good. Sounds like you can hear me okay, right?
Yes, it's perfect.
Awesome. And James, you go by James?
Yeah.
Yes, that's correct.
Okay. Just wanted to make sure that you're here too, since you're the flyer of record.
Hmm.
Awesome. All right. So if you guys are ready, we will get started with the review. Do you have all the team members here, or most of the team members that intend to travel?
Yes, we do have most of the team members.
Okay. Are we waiting on anybody, or is there somebody who
Uh,
just can't join
not
tonight?
in, no, our faculty advisor was unfortunately busy because it's very early in the morning. He like kind of refused to come, but it's fine. Like we have most of our team members, so we are ready to present. Should we give a short introduction of the team, or do we directly go into the verticals?
Um, so before we do that, yes, I want to do an introduction to the team, but I want to remind you. So we need to record this, and then yeah, at the end, what they want you to do, they sent some new messages on the Hero X. They want you to save the file and put it in like a Google Drive or some sort of shared
Yes.
drive, and then email the link.
Yeah.
So
Yeah.
if you want, just so we don't forget, just start it now.
Yeah. I think multiple people are recording it, so that's fine, right? Yeah. Cool. Yes, sir. We are ready.
Awesome. Um, so up front, this is not for points, but this is a mandatory event. It's more of like a safety review. I want to see the rocket, talk to you all about the operations, see some specifics. I'll have specific questions about the rocket, and then I'll let you ask some questions about me. And then at the end, or not me, but about if you have any questions for me. And then at the end, we'll talk about what it's like to be out there at Las Cruces, what to expect. This is your second year or third year you've been out there?
Second, yes.
Okay, awesome. So you guys already know a little bit about what to expect, or a
Yeah.
lot know about what to expect.
Yeah.
Great. So I don't have to worry about that so much. Fantastic. All right, so I'll hand it over to you. I'll let you do introductions, and if you have anything to present, we'll do that. Otherwise, I'll roll into the questions.
Sure. Thank you, sir. So, as you know, we are Team Abhyuday, and this year we have expanded our team to around 50 plus members, divided into various verticals. We have airframe and aerostructures, which has multiple new things like transition and canards, which our leads will explain. We have avionics and recovery, where we are doing SRAD avionics this time, and for recovery, we are trying out reefing and a piston-based ejection. We have the payload system for which we are doing gas sensing versus altitude lab setup. We also are starting a propulsion a vertical, and we plan to move ahead of the COTS motors, and we are developing our hybrid motor, which has been static fired here. But this year we are participating in 10K COTS. Um, and obviously we have the management vertical and some other research payload stuff going on at the back end. But yeah, so we will start off with, I think, the airframe and aerostructures. Priyanshu and Pritish are the current heads of airframe, and they will explain what is new and what all we have done, what's the progress, and how is the situation.
Okay.
Okay, so hello sir, my name is Priyanshu.
And I am Pritish.
So we'll start with the basic description of a rocket. So like our team head has already explained about the basic idea of what we have new in a rocket. Last year we will show you a previous year rocket also, and first we'll start with this year's rocket. So this is the cross-sectional view of our this year's rocket, a Chetak 2. And as you can see that this time we are going with a minimum diameter at the cross section. Our payload is basically taking a 16 centimeter diameter tube. It's a standard 3U CubeSat design, but the casing was thinner than that, so we decided to go with a thinner diameter to save some weight, in which we succeeded. Another aspect that we are working on canard system, so I'll basically brief you down from the top of it. I hope you can see the CAD file and you can hear us, sir. Yes. Okay. So, based on a previous year experience, also we went with a aluminum nose cone tip basic mechanism. A nose cone is just a bond carbon shape. The fineness ratio we have set to 4 for this year in order to reduce the drag as much as possible. Another thing is that we have decided to go with the carbon fiber nose cone here. Our nose cone and fins are the ones that are manufactured out of carbon fiber. Our payload will be secured on a particular bulkhead, which will be fastened with the tubes. Below sir comes a canard system. A canard system is actually one of the most unique aspects of our rocket this year. And the reason why we had a canard system is our last year's experience. So my teammate Pritish will explain more about it.
So the last year, if you had seen our launch footage right here, played. So this amount of spin was not really required. So we thought of introducing aerodynamic roll control, for which we designed the canard system.
And it's just roll control. It's not doing any attitude. It's not doing any,
No,
you know.
it's not doing any altitude or it's not doing any guidance. It's just basic roll control. So, so the canards are basically flat plates. Canards are basically flat plates with tapered off edges, and it will be right before the transition, so that there's no any flow this thing happening.
Have
And
you been able to test it at all? Have you put it in like a wind tunnel or done anything, any sort of testing to see if it, because I'm assuming you've done this with microcontrollers and servos.
yes, but we haven't been able to test it yet because there's a small problem with the attachment of the canard that we are currently working on. One of the there's an attachment issue basically. The canards are ready, but once the attachment issue is sorted in a couple of days, we'll be able to test it out.
Okay. That'll be
And
something to cover in depth when you get out there, because we'll just want to make sure that those canards are going to do what we expect them to do and not make the rocket, you know, go off the intended path. So just explaining that when you get out there, especially if you're still working on the attachment method and maybe possibly working on some code, take some time out there with the safety folks to explain exactly how it works to alleviate some of their concerns. Okay.
okay, sir, sure.
But
And
it's really neat. It's really neat. I like it.
thank you. So moving down from there, we wanted to try a minimum diameter rocket for this year. So we include an aluminum transition, this part you see right here. And moving down from there, we have the upper body tube, in which will house the piston mechanism. In this piston will be having our parachute, and the parachute would be attached on a shock cord, which will be attached to the upper end of the transition, the lower end of the transition, and the upper end of the avionics bulkhead. So yeah,
So
the
quick question about this while we're talking about the piston. Um, is the airframe and the piston, are they made of two different materials?
yes, the airframe is made up of uh, glass fiber, and the piston is made up of aluminum, 6061.
Okay. What is the tolerance between them? Have you figured out what I'm asking, what I'm getting at?
So there is a zero 0.5 centimeter tolerance.
Okay. So there's half a centimeter tolerance difference between the two. So there's
Yes.
no chance of it getting stuck because
No.
of the different expansion rates of the materials. You've got
No.
enough
No.
clearance where it's not going to be an issue. Okay. Outstanding.
Okay. Moving down, we have the avionics bay, which will house our COTS as well as SRAD avionics, and to cap it from below, we have the avionics retainer.
Here you can see the retainer cell. So the thing is, minimum diameter rocket has its own set of challenges, and we went creative with our solutions. We decided to go with a retainer in order to join the avionics coupler along with this tube. So retainer is just a big nut basically, which will allow easy assembly. Another, after below this, basically we have our motor casing, and the engine mount. So engine mount is aluminum 6061. We have made sure that it's easily holds any kind of load. The factor of safety is more than 5 for the maximum thrust of the motor that we are using, which you can see. And here we have fins. So last year we had hand laid up all the fins, but this time we are going with fin clamps in order to secure proper attachment. And the thrust plate is here in order to make sure that the motor rests on it and it takes in the load, extra load that is there. It transfers the load to the body too. So this is the general overview of our Chetak 2.0.
Okay, how is it? How is that motor retained?
So, sir, the motor has a protrusion at the motor block has a protrusion at the center, which will be threaded on which the motor would be screwed into, and from
Okay,
from the end on the thrust plate, there's a cap on which the motor would sit when it's not producing any thrust.
okay.
Move it
So
down.
there'll be a physical screw that goes through that bulkhead to the forward closure of the
Yes,
motor. Okay,
and this is how it's capped.
okay, very good.
Yes. All, yeah. We can show you the rocket right now. One second.
Yes.
Yes. So that's the other thing. So are your is this your presentation, or do you have more to present?
We have our rocket right now ready.
Perfect. Because what I want to do is I want to. So I have a checklist of my own where I want to see the rocket and inspect and actually see the things and ask specific questions about the rocket that are safety related. And then we'll just kind of walk down the list, and then if you could bring the rocket pieces that we're talking about so we can discuss them in depth. Is that okay?
Sure, sir. Yes, yes.
Perfect. So let's see if we can just go from top down. So can you show me the nose cone?
I hope that is visible.
Oh, I see it. Hang on. I gotta get it to where I can. I'm struggling to get the one. Come on.
It's the account
There
of
we go.
Team Abhyuday is actually presenting. I hope you found that.
Yep, I found it.
Okay, cool.
I was trying to maximize that window so I could see it better because it was really small.
Yeah, you can pin it.
Okay, so I see the nose cone. Can you talk to me about the separation point? Where does it separate there?
So the nose cone does not separate. It's a permanent fixture. The separation happens here at the transition.
Okay, yes, that's right. So how is the nose cone held in then? Is it shear
So
pins? Is it bolts?
no, the nose cones are held to the payload. We're using bolts. It's M4 bolts, and then the payload is attached via M3 nut, M3 bolts here,
Okay,
and then there's a canard spare. Again, they are attached with M4 bolts here, and the transition is permanently fixed using M4 again.
okay.
Then here
So,
is where we have the shear pins. Here will be where we'll be having shear pins.
okay, got it.
Yeah.
What size are those shear pins? Are they
Uh,
2, M3,
440.
440? Okay, big
Yeah.
ones.
Yeah.
How many do you have?
Four of them.
Okay. And
Uh,
have you done a separation test on that with the piston system?
so we are planning for the next week. Right now, we are working on the complete assembly ones.
Okay.
We have done testing on the old rocket with the same piston system, but we haven't done on this one.
Remind me, the piston system, is it black powder or is it CO2?
It's a black powder system. So we have a small combustion chamber, as you can see in the piston system. This is where we generate the pressure using black powder, and the piston shoots out.
Okay. Very good. You have
This
a
is a
piston system, so the four 440s are probably a lot, but you have a piston system, so I'm less worried about it because piston systems are usually better about getting the force necessary to separate. So I
yes.
think you're good.
So yeah, we have kept more than a safety factor of 2 for the force required to break the shape ends. Considering that,
Okay. Talk to me a little bit about the load tracing for your payload, because your payload is like 8 pounds. I think that was the requirement. It was something in there.
yeah. So
Um,
8.8
how is
pounds.
it held together? Is it just those screws that I saw earlier looked small for 8 pounds?
So yeah,
Um,
we have 6 of them. So instead of like a few, we have 6 of them uh, to retain them in the place. Also, as you can see, the big holes, there'll be a duct kind of thing attached to this permanently, which is also attached to the payload. So the payload will also be hanging from that to ensure that there's no, I mean, like, the load is distributed between the duct system and the bulk.
are you able to open it and show me?
Just you'll have to.
Because what I'm thinking about is when your main parachute comes open, the G load is really large. It can be as big as 50 Gs, even bigger than that sometimes. So if you think about this mass, this 8 pound mass that is moving down, that suddenly has to be stopped very quickly. It's a lot of force. And I want to make sure that you guys are thinking through the load tracing so that nothing breaks free. Does that make
Yeah,
sense?
so that's the reason we went with 6 screws. The 6 screws were actually an overkill, but that's the reason we went with 6 screws.
Okay, they look
Uh,
pretty small, but it depends on how it's done. So,
so the bulkhead is like I'll try to remove the screws right now and show you. Like,
so have you thought about this force on the screws and the airframe itself? Sometimes what I have seen on rockets, similar to this, is when that parachute opens up, the force is so great it will tear a hole, like a long trail, like a slice through the body tube.
okay.
But
Yeah. So
in this case, it looks like you've got your payload actually probably attached to that bulkhead, and I see a big ring on that bulkhead, so it's probably
yes.
fine.
Yeah, the payload is attached by an eye bolt to the bulkhead, and there's no another connection with the airframe in this. We don't have
Okay.
the payload inside right now, but I can show you the bulk.
Yeah. I'd like to see it. Sorry, I'm making you take it apart,
No,
but
it's fine.
it'll
It's fine.
it will help when Nessa reviews the our video. Did you make the airframe yourself?
So we use the facility of the companies. Like we worked with the collaboration with the companies because we didn't have the facilities here, but
Uh-huh.
we and their guidance as well. Yeah.
It looks good. That's what I was thinking.
So yeah, we don't have the payload right now, but it'll be attached to the bulkhead using a nut and a locking washer.
Okay. Good. Very good. That's what I was hoping. So there's really those screws are just holding on the airframe and
That's
some of the
yeah,
nose cone. It's
yes,
not really a huge load. It's mostly just there to keep the airframe from falling off. The
yeah.
most of the load is being transferred through that bulk plate and that bolt. Very good.
Yes.
Very good.
So, and about the thickness of the bulkhead, the actual thickness required was very low, but
Right.
as the we couldn't drill holes in a very small bulkhead, we chose to increase the size of the bulkhead just to be sure on the loading as well, like keeping the safety factor very high on this.
Very good. Yep.
Yeah.
That's smart.
So, uh, after this, we have the canard bay here.
And that is that's not your SRAD. That's independent of your SRAD computer, or does your SRAD computer also control that?
No, it's completely independent system. It has its own flight computer, as you can see the PCB, and it
Okay.
also has the servos inside right now. You can see in the back. I'm not sure.
How is that powered?
So yeah, I'll have to remove the transition. So we have a bat. No, I have to remove the screws.
You have to remove the screw.
Hopefully, you saw the announcement about lithium polymer batteries.
Yes. So we are using lithium-ion batteries in metal casings.
Okay. I think that was permitted, correct?
Yeah.
Okay. Very
We
good.
were initially using lithium polymer, and then the new rule came up, so we shifted to lithium-ion batteries for everything.
Great. Yeah, I think that's because of the heat that is very hot out there.
Yeah. And when if in case the parachute fails, there's a good chance that it might catch fire.
Yep.
We ensure that there are enough screws so nothing comes out just in case during the
Yeah, I
stops
see.
and everything.
And is the nose cone done a similar way? Is it held in a similar way?
Yeah, so for nose cone, there are again M4 screws which are attached to the payload bay. Uh,
And then the coupler inside that nose cone.
yeah.
Um,
So this coupler has been permanently epoxied to the nose cone because we didn't need to separate it at all.
yep.
So this has been epoxied, and then we have this system. So we have a battery casing. If it's visible, the wires are not done yet. We'll be soldering everything. This was a
Okay.
temporary fixture, but if you can see the batteries, just uh,
Yep. I see them.
yeah.
Very good.
So so the battery casing has been screwed in along with the system so that it doesn't come.
Great.
Not able to show it properly, I think. Yeah. This is a system from inside. So we have a PCB, we have a key switch to trigger it on and off on the launch pad, and we have four servos. The the canards have not been attached yet. We have the canards separately here, all the four canards. The canards are also aluminum 6061 considering the loads and the attachment mechanism. So we didn't want to go with composites with this. Uh, yeah.
Okay. Very good.
So yeah, the
And
transition
then
is also completely hollow from inside. And we'll be having U-bolts. We haven't drilled the holes for the U-bolts yet. We'll be attaching a U-bolt on this side of U-bolt with a swivel link and a quick link, which will be attached here. And the parachute will be hooked via a shock cord to the quick link here.
okay. Very good.
Yeah. So after that, we have the upper body tube. Uh, here, and the upper body tube will store the piston inside in it. We did all the fit checks and pull checks so that we are sure that the parachute deploys. It doesn't get stuck inside the piston. The parachute easily comes out. The parachute right now is completely loaded with two reefing cutters for redundancy, shock cord inside it, the necessary wirings that goes for with reefing cutters. Yeah, and coming to the back of the piston, we have a slot here to ensure that the shock cord has enough space to wiggle around when the system is deployed because the second end of the shock cord will be attached to the avionics bulkhead using an eye bolt and a quick link.
Okay.
Yeah.
And you
Uh,
said quick link? There'll be an eye bolt and a quick link?
yeah.
How big of a quick link?
I can show you the just. So we have two sizes right now. These ones are the smaller ones.
Oh, that's sufficient. That's great.
This is, by the way, this is the avionics bulkhead. We'll be epoxying to the avionics coupler, which I'll be showing you next. And this is a combustion chamber in which the black powder will be loaded in, along with three matches, like two controlled by two different cords and one controlled by the SRAD.
Okay. Yeah, I saw that. I have questions about your SRAD, but we'll get to that in a minute.
Sure.
And
Uh,
then, so are you plugging that hole so the black powder doesn't go, the force of ejection doesn't go back through that hole?
Yeah. So once we have the igniters through them, we'll be plugging that hole. We'll be filling that hole with quick 5 minute epoxy.
Okay. That'll probably be sufficient.
Yeah. After that, this is the avionics bay with switch band. The switch band will have holes for two different key switches to trigger the SRAD and the cords separately. Uh, After that, we have the lower body tube, which uh,
Do you have a switch for each altimeter?
yeah. So for both the cords we have one switch key, and for the SRAD we have one key switch.
Okay. And
Then
you're using, what batteries are you using for your COTS and for
so
your
yeah,
altimeters?
cords. The primary battery is 9 volt for. There are two 9 volt batteries for independent cords, and one 3.7 volt lithium ion for the GPS tracker.
Okay.
After this, moving on to the lower body tube, we have the motor mount inside, which is screwed using M6 screws, six M6 screws.
Okay.
And it for safety, we have also as it is a permanent fixture and does not need to be removed. We have we have filleted with epoxy inside.
Good, good. Because like I said, sometimes those screws can tear through your airframe.
Yeah.
Having an epoxy seal is much stronger and much safer.
Then we have three centering rings that are also aluminium.
Hmm.
Those are being screwed using four M3 screws, and similarly we have created a fillet using epoxy. In,
Internal. Okay.
yeah, so there are three pairs, as you can see. Then we have the thrust plate, which is completely epoxy. So it's in two caps, parts: the thrust cap and the thrust plate. So the thrust plate, this part has been permanently epoxied. The motor slides in, and we can then use a thrust cap to ensure that the motor does not come back. And we
Okay.
have kept enough threads to ensure that even during vibrations, there is no possibility of the cap to unthread.
Yeah. And you've also got positive retention through that bulkhead, right? So it should be fine.
Yes. I'll try to show inside if there's enough. Can someone?
Yeah. So you haven't drilled the hole that's going to go through there yet, correct?
Uh, so the bulkhead already has a thread coming out of it. So in the end, if I'm not sure, okay, it's not visible here, but the bulkhead has a thread, a 3 by 8 inch thread on it, or like a rod kind of thing coming out, which has 3 by 8 inch threads.
Show me on the other side. Can you show me again on the other side?
Yeah, it's a flat plate on the other side. I think it'll be better if we show the CAD of the fixtures to explain it better.
Yeah, because it looks different from the design you showed me.
Yeah, that's
Because the design, I thought there was like that's why I was asking about a hole that will thread directly into the motor so that you're not dependent on that epoxy. Because the motor is going to get really hot. That aft aluminum motor thrust plate is going to get very hot. And then when your parachute opens, all the motor is going to want to come down. And if that epoxy has weakened because it's so hot, then it could come free. But yes, so like this is what you're showing me here. This looks great. So is the plan to do that?
Can you repeat the question, sir?
So I see what you're doing there on the in the photo. Is that the plan? There'll be a bolt that threads into the motor.
Yes, sir. So the motor, the forward closure of the motor has 3 by 8 inches female threads. And last year we went with an eye bolt, but to reduce the number of parts and reduce the chances of the eye bolt unscrewing due to the vibrations, we kept the female threads integral with the motor mount structure. Uh,
Oh, okay. I see what you're saying. So when you put the motor in, you'll have to twist it down so it threads on there.
yeah.
Is that
Yes.
correct?
Yes.
Okay. Okay, that's good. You have positive retention in that. Then you got the M6 bolts, and then you've got the epoxy on that. So
Yeah.
that's not going anywhere.
Yeah.
And you've got a thrust plate at the back. That's good. That's great. You have good positive retention both sides of the motor. Very good.
Sure. So moving on to the fence, we haven't fixed the fence yet because there was a delay from the manufacturing end of the fin clamps. We just got it yesterday night and we didn't want to rush it in for the presentation because we
Okay.
wanted to ensure that the fixtures are proper. But we have machined the slots on the ball tube to where the fins are supposed to go. These are the fence. These are carbon fiber fins. They are coated with primer right
Okay.
now.
How thick are
Uh,
they?
these are 4 thick.
4 millimeters. Okay, very
Yeah.
good. That's plenty.
So moving to the clamps, we these are the clamps. So we have 4 pairs, 8 pairs of these, 2 rows basically of straight clamps, and then we have triangulated clamps in the end or in the top. Uh, so these
How thick are
clamps,
they? They look really thick.
yeah, these are 2.5
Oh
mm.
yeah, very good.
Uh, and we had these were modeled based on 6061, but due to the availability of the material and increased strength, we went with 7075, aluminum 7075, which has almost double the strength of 6061.
Okay, very good.
So and okay, so one thing that comes to having a transition is the rail buttons.
I
That
was
is
just
one.
about to ask.
Yeah. So for the rail buttons, we have something like the protrusions that will come up on the body tube like this.
Woo, big.
Yeah, we have ensured that those are aerodynamic enough. So one of the protrusion will be attached directly to the one of the clamps like this. If you can,
Okay.
yeah, and another protrusion will be attached to the upper body tube. And this is the protrusion. Another protrusion will be attached to the upper body tube, and there'll be rail buttons on both. They'll
So they look about the same height, though. Wouldn't that the idea is you've got your offset so that it comes up here, you have one rail button up here, one rail button here, and it sits in one line. But if
yes.
you're offset both at the same distance, do
Uh,
they line up?
no, so you got it a little. I think you got it wrong. Basically, this one is on the upper body tube, not the upper body tube is the same diameter as the lower body tube. The one that houses the piston, just before the transition. Basically, it's just before the transition.
Show me your separation point again.
Yeah. Can you fix it?
Oh, okay. So your launch lugs are not, you don't have one on the larger body and then one on the smaller body. They're both on the smaller diameter body.
Yes.
Okay, makes sense. That's better. I
Yeah.
like that idea.
This was to ensure we have enough gap between the bodies and to avoid the manufacturing errors, the changes in the diameter of the bodies that can't be predicted during the analysis, like what the final diameter will come up to be. So this was chosen to ensure that we have this uniformity and the launch is easier there in the USA.
Great. Yep. That's a good
So,
idea. I like it.
is like okay. Then moving on to the avionics. So this is the avionics setup. It's a 3D printed bay, which will go inside the avionics coupler. And this first thing is the battery holder, which will these are the lithium-ion batteries that we talked about. The lithium-ion
What batteries are those?
lithium-ion batteries. So, metal case.
Sorry, I can't hear anything.
Am I audible? So, am I audible?
Is it on mute? Can you all hear me?
Hello.
We can hear you, sir.
Am I audible?
Huh.
So am I audible now?
Hang on. I can't hear. I think it might be a problem on my end. Oh, there it goes.
Can you get some other phone? Can you talk and just say the field request? Hello.
Yep.
Yeah. Can you give?
I don't know if that was me or you. I'm not sure what that was.
So am I audible now? Hello.
Yeah. I I'm losing video on the of the avionics.
I'm changing the camera, so I think it should be visible now. I've
I
changed the
can
device.
barely hear you.
So I've changed the device. If you can see, it'll be in on another device.
Hang on. Sorry, I'm trying to get the window maximized. Why isn't it helping? Okay, I see it now. Can you guys hear me? I still can't hear anybody.
I hope it's visible now, sir.
Yep, I can hear you now and I can see it. Okay,
Yeah.
sorry about that.
So the batteries are lithium-ion batteries. These are metal-cased batteries that we'll be using.
Um, Normally we don't see springs in avionics batteries. Is because if the vibrations and the forces can cause a momentary separation of those, are those soldered in place? Is there a
Uh,
way to solder those in place?
so
James,
these
what
were
do you
the
think? You're the flyer record here.
I think you have a good point, but this I think those springs are pretty fairly compressed. So I'm not sure how worried I would be about it.
Okay. Where are those positioned in the direction of travel? Is it in the same direction as those springs, or is it like normal to the springs?
no, they are normal to the spring. So the direction of the travel is normal to the springs. So the battery holder goes in this direction inside the bay, and while the travel
Okay.
is in this direction.
Okay.
It's
I
perpendicular.
would. So I don't know for sure. I would check the guide. But
Yeah.
if I had to change anything, I would change the mounting of those batteries. That may be a question, and it may get you. They may send you back to fix that before they sign off on your safety review, because I don't think I've ever seen anybody approve batteries held like that.
Sure. Okay. So we'll reduce the risk. We'll just solder the batteries. We'll solder the connections to the batteries just to reduce these kinds of risks.
Yeah.
So after that, we have the power distribution board here, which has the antenna for the telemetry as well, the SRAD telemetry. I can the
Okay.
board has been
Have
wired.
you
Yeah.
have you been able to test the SRAD? Have you had a flight test? What kind of testing have you done on the SRAD? That was one of the things I had questions about on the last report.
Yeah. So as of now, we don't have a flight we don't have flight permissions in India, so we couldn't fly the rocket. But we have done ground testing on the SRAD computers. We have done using lifts and to see the altitude measurement and to see the ejection system if it works fine. But we couldn't do with the flight. But we have done the vibration testing on the PCBs. in the aerospace department, we have machines that can simulate the vibrations of rocket launches. So we have put them through the vibration testing to ensure there are no loose connections, or there is no chance of the connections coming out during the
Okay.
test during the flight.
How is how are they the E matches activated? Are you using a MOSFETs? Are you using relays?
Yes, yes, sir. We are using a MOSFET. Like we are using a 5 amp steady current and 16 amp max pulse current MOSFET. So we tried testing it with the E-match and was working fine.
It worked with an E match.
Yes, sir.
Okay. Do you have pull down resistors on the gates of your MOSFETs?
Yes, we
That
use that.
way you do?
Yeah.
Okay, good. That will help reduce any, stray electrical signals from accidentally firing your pyro charges. Okay.
Okay.
I see a telemetry system. What is your telemetry system? Is that SRAD? Is that commercial? Do you have both?
So we have
So
one. Yeah. Yeah. Okay. So in the SESRAT system itself, we have a telemetry system. So you can see we are having a LoRa module. So it will we are having a LoRa module. So it will send all the data to the ground station of a system, which is also another similar LoRa module, which is paired up in addresses. And we are transmitting all the data from all the sensors, including the MPU or our inertial measurement unit and the GPS coordinates and pressure data, altitude, etc. We also have a course telemetry, which is a GPS tracker, which you can see here. Uh, the GPS tracker is a featherweight GPS tracker.
Okay.
So we also have the ground station for that. This is a redundant uh, telemetry system in case we are having any failure in the GPS coordinates, so that we can accurately record our rocket.
Okay. So you said that is multiple addresses. You mean multiple frequencies on your SRAD?
We are
Or
using
is it
only one, but we can set it according to the code.
okay? What frequency band? It is on the ham radio, like 400 megahertz, or is it 900 megahertz?
It's in the 900 megahertz range.
Okay. And you can set it, you have the ability to set it to just one frequency, right?
Yeah.
Okay.
Yeah.
It's not spread spectrum and hopping or anything like that.
It is using a LoRa protocol, so it's slightly spread spectrum, but
Yeah, it's
can
not quite,
convert in
but
the channel.
yeah. It's not using like 60 channels or anything like that.
No.
Okay, very good. That'll be one of the requirements. I mean, you remember from last year probably, but they'll give you one or two frequencies, and it'll be the frequencies that you get, and you have to stay on those frequencies. The 900 megahertz is usually very crowded, so it's important that all the SRAD systems stay, on one, narrow band, one frequency and a relatively narrow bandwidth. What is your bandwidth that you're using for LoRa?
The bandwidth that we are using for LoRa is around two. hmm, We are using around 256 kilohertz, I think. Kilohertz, yeah.
250 kilohertz. Okay.
Hmm.
Um, Make sure you tell them that because I think they have 100 kilohertz slots for
Actually,
each
we can
team.
control that also in the code, so we can adjust it accordingly. For testing purposes here, we use 256. That's it.
Okay, because I've not you, but I've seen other teams use 500, and that's a lot of bandwidth. Um,
Okay.
so the more narrow your bandwidth, the better, which will minimize the odds of you having interfering with other teams and other teams interfering with you. So okay. Very good. And what type of talk to me a little bit about more of the testing? Like, how are your pyro charges? What are your algorithms doing for your SRAD computer? Are they barometric based? Are they IMU based? Do you have sensor fusion algorithms? What kind of safety features have you coded in there to where if your motor chuffs and the rocket doesn't quite go, or you have to replace an igniter, or something like that happens? That it won't accidentally fire charges? What safety features have you coded?
Okay, right now it's totally barometric based, but we are having an IMU as well. The current code is totally barometric based, so it's checking the
altitude data regarding what stage of flight it is right now, where it's liftoff, where it has reached the apogee, everything. So the like I said, there's a pull down resistor connected to the MOSFET in to prevent an accidental firing. So the code,
So
the
it's
main
it's
part is
barometric. It
yeah,
sounds like
right
it's
now it's the
barometric. And what is
yeah.
your threshold? Is it just looking and constantly recording and looking for it to come back down, or are you using a smoothing algorithm?
We are using a moving average filter in a width of 20 window size. So we are passing it to a moving average filter, then checking for a constant decrease in the altitude or increase in pressure.
Okay. Is there what happens at the field is you know, as you know, it's very windy, and your holes on the side uh, can have pressure variations because the wind is blowing by them. Is there a chance that those pressure variations, those fluctuations, could activate your flight computer? Is that possible?
Uh, there's a slight possibility, like if the pressure variations does not vary very frequently, the moving average filter won't be able to accurately filter those variations. So there's a slight possibility in that case.
Okay, maybe consider that for some testing on your flight computer, is whether or not some wind variations could possibly activate it. Maybe have it sitting there and then just blow across the holes and see if you can get it to activate.
Okay, sir,
That will help. I think the requirements. So check the guide again, but I think the requirement is a flight test of the flight computer. You do have two commercial systems, correct?
Yes,
yes,
sir.
sir.
We have an Easy
Okay.
Mini and a Raven 4 on board for
Okay.
Fox.
Very good. Because they may ask you to not use your flight computer for deployment. You still probably could use it just fine for data collection and telemetry. But because it's not flight tested, just be prepared that they may ask you to not use that for the actual flight for deployment. Okay.
Yes, sir. We can keep it. We also have plans that if we have kept it in mind, and we also have plans that in case they do not allow us to use igniters from the SRAD, we'll just use a trigger system that the data that we are recording to see when it's triggering a supposed igniter that could happen there instead of triggering a real life igniter.
Okay. I think I caught that. Okay, and then that your SRAD computer is powered by the lithium ions, and then it looks like you've got a 9-volt powering the commercial systems, and then you've probably got it looks like commercial lipos recommended by the manufacturer for the other systems. Is that correct?
Yeah. So we don't have lipos on board anywhere. We have 4 lithium-ion batteries that are powering the SRAD system, along with a 9-volt battery that will be supplying the current for the pyro charges for SRAD. Then we have 2 lithium 9-volt batteries, nickel cadmium based batteries for the COT system, and as 3.7-volt lithium ion for the GPS rack. I
Okay,
think it's
very good. Good. Okay.
about the attachment mechanism. The batteries for the cords are zip tied to the avionics bay to ensure they don't move. We have 2 perpendicular zip ties and 1 parallel zip tie along. So basically 2 similar to this one, and one that will go from here to the other end to ensure that the batteries don't move at all for
Okay.
all the 3 batteries. While these batteries have fixed, these batteries have been fixed to we have a separate 3D printed battery holder. Now that is suggested about the springs, we'll also look into the soldering. But we have 3D printed a battery holder which can be screwed to the base of the of the avionics bay, and the the 9-volt battery will be zip tied to this battery case
Okay.
in a similar
That
way.
all looks good. That looks good. How is it held in the avionics bay?
Yeah.
Is
So
it
we
does it slide in and out and it's bolted in?
yeah. So as you can see, there's
No, I
for
mean the
3
whole
bolts.
stack, the whole big stack, not just the batteries, the whole
Okay.
avionics unit.
So there are 4 M4 bolts that go on the top, and it's attached to the avionics bulkhead. Just a second, I'll bring the avionics. So as you can see, there are four holes here, threaded holes. These, along with the four holes on the, yeah. And after that, for another safety, we also have the retainer ring. Uh, so this is a retainer ring that will come in the end of the basic. Okay, the whole system will be something like this. The retainer ring will cover the end part, and it has a little bit of material coming out which rests on the avionics coupler, and this retainer ring is attached to the coupler in the end using M6 boards.
Okay. Trying to think through. You guys have a different design. You have a single parachute, right? That you're just reefing. And so how is this? Is the payload above that, above the avionics, or is the avionics above the payload?
The payload is above the avionics. The payload is in the nose cone, while
So the
payload is right below the nose cone, like in the shoulder of the nose cone, then followed by the canards bay, and in the upper body tube we have the piston inside which the parachute would be kept, below which is the avionics bay.
okay. So where does the parachute attach? Where does the
So
shock cord attach?
the shock cord is will be attached to the avionics bulkhead one side. I show that. So in the video you can see eye bolt with a quick link on which one side would be attached. The other side would be attached to the top at the transition. We would have a U-bolt, a swirl link, and a quick link, which will
Yeah,
attach the
up
shock.
there. But I'm trying to think about the load, the force on how does the force from the shock cord get transferred to the motor? Is it through the avionics bay?
Yes, it is through the avionics bay.
Through the avionics bay, and the avionics bay is made of plastic.
No, oh, sorry. It'll be through the body. So the avionics bay is epoxy to the this avionics coupler over here. That will be screwed. So the load transfer happens through that.
Through the external screws that go into that plate right there, where the piston fits into.
Yes. This plate.
That plate. So that plate is just bolted into the airframe.
No. So this plate is epoxy to the coupler. That coupler down. Sure. Now we have the retainer here. This is bolted.
Uh, so I can, if you'll see the video feed, this is the avionics coupler with the switch band. Can you stop
Yeah.
it? So the bulkhead is epoxied permanently to the coupler here. Will be epoxied. This will slide in and will be epoxied permanently to the coupler, which will be the load-bearing surface, while the avionics bay hangs from the coupler using the four M4 screws. And to ensure that the avionics bay does not drop down, we have this retainer ring, which is attached to the avionics bay using the screws.
Okay, I see that. And then explain how show me how it goes into the main tube.
Yeah.
And I'm sorry this is taking so long.
Wait. So the bulkhead will be epoxied to the surface here, and the whole upper body tube will come inside. The whole upper body tube will slide in here.
Yeah. And then how, so that bulkhead, the aluminum bulkhead goes into that section right there. How does that section transfer the load to the airframe? Is that other
Through the
section
switch
bolted
bar.
in?
The this bulkhead ensures that all the loads are through the avionics coupler and then to the switch band and to the lower body tube.
No, I'm thinking the other way. So the pulling force of your main parachute opening. So I'm
Yeah.
not thinking of your motor thrusting. I'm thinking your main
Okay.
parachute opens up and there is a huge force pulling on that ring right there. How does
Yeah.
that transfer the load back
So
to
okay.
and make sure everything doesn't separate and break?
Yeah. So to ensure that the avionics bulkhead, which is epoxied permanently to the coupler, will be pulled, and which results in the switch band that will push the that will transmit the force through the upper body tube.
But then that still can slide out. So
Yes.
how does it not?
So yeah, the holes are not drilled yet, but if you so so as you can see, there are 4 holes here,
Ooh.
and the retainer ring that way, the retainer ring that I showed earlier. Similar holes will be drilling in the upper body tube that has not been drilled yet, but there will be M6 screws, 4 M6 screws that will go through it, which will permanently attach the avionics coupler to the lower body tube.
James, do you see what's going to happen? Are you seeing what I'm seeing?
It could just rip straight through that.
It's gonna rip straight through that fiberglass when the main opens, and the back half is gonna separate.
Hmm.
Is that that's exactly what I was thinking? Is that what you're thinking?
Yeah.
So team, do you understand what we're saying?
I think you are afraid about that the 4 M6 screws that are attached to the A-frame might just shear off. Uh,
So I think that they're going to stay right there. What I think is going to break is the hole in the fiberglass right there. Because those holes in the fiberglass right there are transferring the entire load of the rocket, of the lower half of the rocket, to the parachute. You have that like 3 to 4, maybe 5 millimeters of fiberglass right there at the back end of that hole, and that's it. If that breaks, then the whole section's going to come apart and your motor is going to fall. You'll have everything undershoot, but your motor part is going to fall out.
okay, yeah, I
Do you
understand.
see?
Yeah, yeah. So okay, uh, so that what we can do is then we can replace the retainer ring and we can have a structure which comes extended out and epoxy it permanently to the body tube, and the avionics bay rests on it.
So do you need to have that section, that back half come out? Because I would almost say epoxy and then screw in that section and just make it permanent. Do you need to be able to get in there?
So what our plan was right now is to epoxy this bulkhead. So we'll need access from this side.
Oh,
Yeah.
yeah, I see what you're saying. Ugh. Hmm. Yeah, that's a
But
tough one.
we might have the same problem if we screw this bulkhead to
Yeah,
the
you will.
yeah.
You're exactly right.
We had a similar mechanism last year where we had four M6 screws on the body tube, which fixed the avionics coupler, and there was not even a little damage to them during the deployment.
It's really thin from my perspective, and I'm just worried that you've got your motor case, you've got all those big fins, even though they're carbon fiber. You got the lower airframe, you've got all those metal components in the back, plus the motor, and that's going to be pulling on those little spots. We don't have to solve the problem right now, as long as we have identified the problem. What I would say to you is think through it, and then talk to James as your flyer of record, and then talk to your mentors to try and come up with a solution, and then work with them. I know you're still not done, and you're working on other things. We'll move on in the interview, but this will be something that you guys need to fix before we get there, because I really do think that will probably the chances of it breaking and the lower half of your airframe coming free are pretty high at this point.
Okay, so we'll surely keep that in mind. We'll see what kind of things the design can we come up with, and we'll surely mail you the updated design accordingly.
Yep,
We'll
that would be
discuss with
great.
James and our mentors and move forward with a new design on the listing.
Yep. Okay. Um, we've covered a lot, and we're at an hour. Let me look at my notes really quick, and then I'll ask just a few more questions, and then we'll wrap up. Okay.
Sure, sir.
So let me just look at the questions that I have here. We've covered almost all of them, but I just want to double check if there's anything else. How long are your shock cords? The shock cords for the parachutes?
Uh, so the total shock cord is 15 meters long, sir.
15 meters? Okay, very good. And what is it made of?
Uh, I think it's nylon based. I'm not sure about the material. These are we are reusing the shock cords from last year. Okay, sorry, my
Okay.
camera's on. I'm really
Are
sorry.
they thick, or are they like, okay, you're good. That's good. And they're not damaged from last year. They're not burned or
No.
singed or anything.
So we had a redundant pair that we are using this year's.
Okay, great. And then you're attaching the parachute to that with quick links.
Yeah.
The quick,
So we have the
which
quick
showed
links
me.
that I showed earlier.
Oh, that's right. Yep. Very good.
So the quick links and the shock cord isn't coming out from this end of the piston,
Yep.
which
And how
has
big is your main chute?
it's an 8 feet parachute. 8 feet.
8 feet. What is your expected descent rate on it under 8 feet?
It was around 16 feet per second.
On an 8 foot? Is it hemispherical?
It's yeah, CD 2.2 CD. It's toroidal. Sorry.
Okay. So it's got a higher higher CD. Usually it's I see them in the 10 to 12 to 15 foot range. So yours is half as big, which means you have 1/4 of the area. So that I typically see. And then your plan is to refit. Explain again to me how you plan to refit and then open it.
Yeah, sure. I think avionics.
So for reefing, we'll be doing basically uh, at the skirt of the parachute we'll have certain loops which we have that can be shown actually from the parachute. So at the skirt of the parachute, we'll have loops through which the reefing cord will pass. So we have a reefing ratio of around zero point 0.7. So according to, we'll have a radius of 3.2 feet. That is, our main parachute will be acting as a drogue parachute.
Yep.
So with this particular reefing ratio, we had certain tests, and with the reefing cords along, and in the reefing cord, we will have two reefing cutters for redundancy, and the reefing cutters, when given the trigger, will basically cut the reefing wire, and the full deployment of the parachute will happen, and this will occur at 1,000 feet above the ground.
Okay. Since you have two reefing cutters, will the parachute open if one of them fails, or do both of them need to work before the main will open?
So could you repeat? I lost you.
If one of the reefing cutters fails, will the
Yes.
main open?
If one of the reefing, no, yes,
it will still open. So you don't need both of them to work correctly. You need
So we
one or
have
the
a
other.
redundant system for that.
One is for redundancy, yes. If one fails, then the other will work with certain time delay, so the parachute will definitely open at 1,000 feet.
Okay. But you've rigged it to where all you need is one to cut and it
Yeah,
will open.
yes.
Okay, very good. Very good. All right, let me look at. There's just a few more questions. Have you bought the motor already? Correct? Are you going to pick it up on site?
Yes, sir. She have bought a motor.
Are you shipping it with you, or are you picking it up in the U.S.?
No, we are picking it up in the US directly at the launch site.
Okay, very good. Like from Animal Motor Works or from Aerotech or somebody?
Animal Motor Works.
Okay, very good. And then what is your igniter? Did you buy an igniter from him as well?
No, we'll be getting it on the launch.
Okay. Um, check with him. He sells igniters as well. There are you have to have the double redundancy, just like you did last year
Yeah,
with
yes,
the
sir. So
igniter.
the one igniter pair is included with the reload kit that we bought. It was included with the kit in that set. And last year also they provided it on the launch site to us while getting the reload kit from them.
Okay, very good. And covered all that. Covered all that. You all have vent holes, correct?
Yeah, so we have not drilled them yet, but we have planned, we have calculated the sizes necessary and the number of vent holes that are necessary in the body tubes.
Okay, very good. Covered that. Okay, that's good. Um, that's it for the questions on the rocket. It looks good. You guys have a little bit more work to do. We identified at least one problem that we need to work on. Well, really two. One is the batteries, and the other is the load tracing. But like I said, work with James and work with me as you find a solution for that, so that we're going to be safe and that nothing's going to break free when the main opens up. Do you have any questions for me at this point?
So one thing is, if we just increase the number of screws, will that be better, or is it better to just replace the whole system and go with something new?
I don't know. I'll let you guys decide.
Okay,
I
sure.
I don't think I'm actually allowed to tell you. I'm allowed to identify problems, but not necessarily solutions.
Okay, okay. Yeah. So we'll see the analysis part of it. We'll see how if that's possible, if modifying the whole the system itself is possible, or should we go with a new system?
Say again?
We'll look into it. We'll see if we can just modify the same system, or should we go with a new system?
Right. Yeah. Just decide for yourselves.
Yeah.
Yep. Any other questions for me?
Um, uh, Good evening, Mr. Sparkman and James. I'm Pratin, and I'm the controls lead. So I wanted to talk about one a problem that you identified with respect to the canards, which is that when the canard control surfaces deflect, you would see the wiggle in the rocket while it's going up. So I want to tell you that inform you that we are implementing a fail-safe system where while the rocket will be launched at a 5 to 6 degree launch angle, but if the while the rocket is flying while the canard system is active. If the pitch goes more than about 12 and 15 degrees, we'll be switching off the canards and bringing it back to zero deflection. And we
Very good.
also have other fail-safe mechanisms where if one motor stops working, we would deflect the other diametrically opposite motor so that it cancels out the pitch and other moments. So that is
Okay.
something that I wanted to add.
No, that's great. It's good to think through that, and it's good to hear you've thought through that. Great. Thank you. Anything else?
I just had a question about the like length of the transitions for your coupler for the avionics. How long is that section that goes into the rocket? Because it looked a little less than 4 inches to me.
Okay. Yeah. So as discussed, I think this was one of the things pointed out in the first report. Uh, so we increased the length of all to keep it 1.2 times the diameter of
Okay.
the rocket. So it's it's a little more than 4 inches. I'm not sure about the exact conversion in imperial from myself,
Yeah,
but
that's
yeah. So it's around 1.2 times the diameter of it's 5 inches. So it's 5 inches long either side. And even for the transition, earlier it was shorter. The length was less. The aft part had a smaller length, but we have again increased it to 13 mm, which is around, it's 13 centimeters, sorry, not 13 mm. So get it around, it was around 1.4 1.4 times the diameter of the rod.
okay. Cool.
Yeah, that was a great. Thank you for doing that. That was something we identified early on.
Okay.
And it looks really good now.
Cool.
All right. Anything else? What I'll do now is I'll move into talking about just kind of what you guys' plan to get out there is, and then about a little bit what you can expect this year out there at Las Cruces. So does everybody who's traveling, do they have their visas? Is there anybody who's still waiting on anything like that?
Yeah, so visas are not yet sorted. Some of the members already have the visas because of the last year, but we have applied for the same procedure. We're following the same procedures because so the waiting period for US visa is actually more than a year in India right now. So
Still?
yeah,
Wow.
so we can't go through the normal procedure, and there's something called an emergency visa appointment request that we can apply for just within a month of travel. So it opens up only within the month of a travel. So we have already filled for that, and we'll get a reply probably by tomorrow or day after tomorrow about the except the slots of the emergency slots for our visa. This is the same procedure that we went through last year, and it was very smooth for that in that sense.
Okay. So if the visas don't come through, you still have members who can travel and compete at the competition, correct?
Yeah, so we have three members who have visa that will be traveling already, but we are not sure yet if we'll be then coming for the competition or not. It's still on the deciding part because three people I don't think will be able to complete the
How many are waiting on visas still?
12 people.
12?
Yeah.
Okay. Wow. That's a lot. Okay. Um, just keep in contact with me and keep in contact with Ezra if you anticipate that if something it doesn't come through or you have issues, just keep in communication so that we know what to expect. Um, have you got airline tickets and you've got a travel, a hotel, accommodations? Do you have all that yet?
Yeah, so the flight tickets for all the 15 people have been booked, and we have booked an Airbnb in Las Cruces for the stay. And our travel, the rocket shipment has also been sorted out, and we'll be shipping the rocket by the end of the month. And we have a contact in New Mexico State University at MSU who are willing to store it and receive it for us.
Okay.
So they'll be receiving the rocket in our end, and we also have two alumni in NMSU that are really helping us along the way.
Okay. Very good. And you've got sorry, noise in the background. Do you have like a truck or a vehicle for you guys to travel out there once you get there?
Uh,
Yeah, I'll be providing the truck.
Oh, okay. Very good.
Yeah.
and thank you so much again, James, for that. And
Oh,
along with that, we'll be booking a 15 people traveler for, and we have alumni that can drive us around till the launch site for that.
Okay. Very good. Um, just like last year, when you guys are out there, when you're traveling to it, make sure you have your passports with you because there is that border checkpoint.
Yeah.
So don't forget about that again this year. Sometimes they check, a lot of times they don't. But you don't want it to be the one time that you get checked and you don't have it. So make sure you have that out there with you. Um, just like last year, it'll be similar operations and it'll be similarly hot.
Yeah.
So you can expect that the winds are going to be, it's going to be about 110 degrees Fahrenheit. I think that's close to like, what is that? That 50 C, something
Yeah.
like that. Really hot.
I mean, we are used to the hot temperatures here. The temperatures here in Chennai, the city we are in right now is around 50. So temperature
Okay.
might not be high, but it feels very high because of the humidity.
I know that the climate in India varies depending on where you are. India's big,
Yeah.
so I couldn't remember where you guys were at, but yeah, you guys are familiar. So just like any hot environment, wear loose clothes, long sleeves are a good idea. Hats, sunglasses. You're going to be out in the dust and the heat all day. Make sure you bring water. Um, I say bring 2 liters of water for everybody the very first day, and then see how it goes for after that, but bring too much water to begin with so you know how much you use every day. And
Sure.
definitely bring too much water when you plan to fly, because you'll need a lot of water when you go recover, just
Yeah.
like last year.
Uh,
Okay.
One more thing I would like to say is I would like to thank ESRA for the last year. So there was an incident that happened last year while we were returning from the launch site. The car we had, the hood of it, some kind of accident happened. The hood flew off and hit the
Oh,
windscreen, and we were stranded in between. And then the ESRA officials who were passing by saw us and they helped us out. They towed the whole vehicle with along their truck to the till
oh
last
wow.
process. So I mean, we can't thank you the team enough for that. And there were a lot of incidents last year. Like there are two of we had three vehicles that we hired, and two of them broke down. I don't know why,
Oh my
but
goodness.
yeah. So, but ESRA helped us a lot, even on the launch site. A lot, and this was other than the competition that they stood out of the way and helped us out. So I would really thank from team side. I would really thank ESRA team for that.
Oh, you're welcome. There's good people out there. They're not going to leave you hanging. They'll always help you out. um, and like that, it's to always communicate. So if you're having trouble or you're having difficulty or you don't know what to do or questions, we're very focused on safety. So always just ask somebody, and we'll be more than happy to help. um, I'm trying to look at the rest of my checklist. Looks like you guys are good. You got the hotel rooms, things like that. um, they have things in here like don't paint rockets in hotel rooms, things like that. Just be cognizant. And then it'll be flight operations will go pretty much like last year. So, and expect long lines. It'll be long days. The very first day, make sure the most important thing you do besides getting checked in is getting your safety review. Try and get that as soon as you can. If you guys get delayed, like say your flights get delayed and you're going to show up late, just make sure you communicate with us so we know that you're on your way, something happened, and so we'll make space for you, and you're not going to get left out. So just make sure you communicate with your flyer of record. Make sure you communicate with ASRA, especially if something is going to delay you, so that you aren't penalized unnecessarily. um, and then also, it'll be just like last year. Expect long lines. You'll be waiting. It'll be busy. First come, first serve at the pads. It's going to get windy during the middle of the day. Expect just like last year, about the middle of the day will shut down. So you'll get 2, maybe 3 racks of flights in each day. So come to the flight, the launch site as prepped as you possibly can, and as ready to go as you can, so that you have a good chance of getting through that line and getting through that queue. Um, Another thing to think about is, or to know that this year they're going to provide tents and tables for the teams, so you don't have to worry about that. You'll have to bring your own chairs, but tents and tables will be provided for you. So like last year, some teams didn't bring a tent and they got stuck and they're very hot. Everybody will be provided one. These are big tents, so it'll be like very, very large tents and then many, many tables underneath. So that's what you can expect out there. And then flight and range operations will be very similar to last year, where they're going to go in waves. You're going to go load the rocket, the team will leave, then your flyer of record and one team member will finish the rest of the operations, and then everybody will go back to the tables or to the bleachers. And then just like last year, when you get there, it'll be very exciting, but make sure you're listening, because they're not going to fly until they say, hey, yes, we are ready to fly, and yes, we have live telemetry. So just be ready and read through those procedures as well. Okay.
Yes.
I've been talking a lot. Do you guys have any questions for me at this point? We're pretty much ready to wrap up unless you guys have questions.
Not specifically right now. Like if we have, we'll surely mail you. If and we'll also talk to James about that.
Okay. And then, oh, I forgot to mention, but you guys are probably already know this. Make sure you bring long pants and boots out there. Don't be in tennis shoes and shorts. It's not going to work out very well, especially if you have to go recover.
Yeah.
No. Expect all
The
the animals that you cross are out to get you and hostile. There'll be ants. If you hear a snake, stop. Find the snake and then back away from the snake. So.
Yeah.
All right.
The tents did make us a lot happy. We almost had our tents like the tents almost flew away last year. We had 11 members holding down the tents just to ensure that the tents didn't fly away last year. It was so windy.
Yeah.
So that was one of the happiest news we had on the rocks this year.
Yeah. I was happy too. Okay. James, do you have anything to add or any other questions for me or the team?
No, not at this moment. No.
Okay. All right. Just make sure when you end, you post it and don't forget to provide the email to the link to ESRA. And then as you've worked through the problems we identified, just communicate with me and communicate with James. Okay?
Sure, we'll do that, sir. Any overall feedback for the team in general? Anything you would like to see in this project overall?
You guys had the most ambitious project that I graded by far.
Thank you. Yeah, for the second
If
launch, we went a little too ambitious, but we hope it all works out on the launch. So we look forward to meeting you in New Mexico, sir.
the quality that you guys have done, the complexity that you've accomplished, the complexity of your design, the complexity of your avionics, just the way you approached your engineering with having the two different body diameters. I haven't seen anything like that from any of the other teams. If their complexity was a 5, your complexity is a 10 out of 10. So um, highlight some of these things in your poster competition. You guys put a lot of effort into it. It looks really good. Make sure you finish it and get ready to fly, but highlight these things that you've done in your poster competition because they are unique. I haven't seen any other team do something quite like this, at least not in the teams that I'm grading and on the teams that I'm working with this year.
Sure. Yeah, we'll do that. So we did try to innovate, and we hope it works and the launch is successful. So we will participate in the poster session as well, and we are preparing the materials for that. Yep. Thank you so much for your feedback, sir. We'll get back on the couple of things that are to be looked into via email, and we'll be in contact with James as well. So yeah, I guess that's about it from our side. Thank you so much, sir.
Thank you guys. Thank you, team. Well done. Good job.
Just to add
Thank
up on
you.
that, we are planning to get a more complicated rocket next year. We are planning to put a hybrid in it next year. We are working on the hybrid engine right now. We have done 4 static fires till now. We are
Oh
scaling
wow,
it up.
that's awesome.
Yeah, the last static fire was actually yesterday. So we have completed 4 static fires as of now, and we are moving into the the scaled up engine, the complete scaled up engine for the flight, and probably you'll be seeing us with a hybrid engine next year.
That's fantastic. Good luck.